In this video, we're going to look at how we can transform quadratic functions just based off of the equation itself. So something that's really important to know is what the parent function is. The parent function is just f of x is equal to x squared, and we compare everything back to the parent function. And then the other important thing to note is vertex form. There is an a value we're going to look at, see what that does, h, and k. And then the next thing I want you to write down, it's going to sound funny, but it's going to help you, I promise. So in an effort to remember how the transformations work, I always say Hank lies, and you're going to think I'm crazy, and Kelly tells the truth. And you'll see what I mean in just a hot second. Okay, it's just an easy way to remember what does the H do, what does the K do, and what does the A do when an equation is written in vertex form. So we're going to look first at, well, what does the K value do? And so notice where K is in our equation. It's on the outside of the parentheses. It can be adding or subtracting. And so in A, notice here's our parent function right here. Notice how it's passing right through the origin. Okay, the x squared plus 3 is in green, and I know that your copy is not in, it's in black and white, mine's in color, so try and really pay attention to this video for it to help you. But what the 3 did is it simply moved it up 3 units. Moved up 3. Okay. And then so looking at example B, here again is our parent function going right through the origin. And now this equation says it's x squared minus 4. So notice how it moved down 4 spots. Down. And so that's what I mean by Kelly. Kelly tells the truth. So if it's plus 3, we're going up 3. If it's minus 4, we're going to go down 4. And so looking at these practice problems, let's do 1 and 2 at least together, and then you guys can try 3 and 4 on your own. So in number 1, I've got negative 7 or minus 7, so I'm going to go simply down 7 from my parent function. Now number 2, I like that it's trying to trick us because it's not written in standard form, so I'll actually rewrite that, making sure to take the signs in front. And so since I have plus 5, I know I'm going to move up 5. So then number 3, hopefully what you did was you changed it around, writing it x squared minus 5. So that means it would go down 5. And then in number 4, I have plus 1, so it's up 1. So now, what does the number on the inside of the parentheses do? So that's H. This is Hank. So Hank lies, right? So Kelly told the truth. Whatever it said, it was plus 3 went up, minus down. So Hank is lying, and it's going to be also a horizontal movement. Okay, this is Hank does this, Kelly does this, up or down. So Hank on the inside of the parentheses, we'll see in an example C. So it says x minus 2. Now notice we're always comparing it to our parent function right here. It's probably really inconvenient that I just wrote in red. So I wonder, let's see if I can change the color here. Let's make it green. So my parent function here, okay, and then then we changed our parent function to this, x minus 2 squared. Notice how it moved to the right, 3. I'm sorry, right, 2. So you would think naturally it would go to the left, but that's why I say Hank lies. So we went to the right 2. So then looking at example D, again with my parent function in comparison right here in the middle, I added 1 now, and notice how it went to the left by 1. So when we have a number on the inside of the parentheses, it's a horizontal move, and it's the opposite of what it's telling me to do. So in our practice here, number 5, I'll do with you, and I want you guys to do 6 and 7 on your own. So I see minus 3 on the inside, so that means it's going to go to the right, 3. Number 6, it is plus, so I'm going to go left, 6. And then in number 7, I have minus 8, so it'll go right, 8. So what if we put the two together? What does that look like? Now we got Hank and Kelly. So remember, vertex form. So maybe copy this down really quick. The more you write this, the more likely you're going to remember. So f of x is equal to a times the quantity x minus or plus, we'll make it minus h squared plus k. So remember, Hank's on the inside, he's shady, he's hiding something, so he lies. K tells the truth, Kelly. So in E, example E, again, we have our parent function here right in the middle. And so we kind of already know what's going to happen. We're going to go up 2 and to the right 3. And let's even see if that works. So comparing just like my vertex. Okay, let's see if I can write. Here's my vertex. And I move 1, 2, 3, up 1, 2. So that makes sense. So I'm going to say up 2. And maybe even say that that's my K value. And right 3. And that's Hank. That's the inside number. So looking at example F, okay, I can predict, well, I'm going to go down 1 and to the left 3. And so comparing that to my parent function here, okay, let's test that theory. So I'm going to the left 1, 2, 3, and I went down. So I was correct. So I'm going to say down 1 and left 3. And it doesn't matter which order, if you say up or down, left or right first. It doesn't matter. So why don't you guys try number 8 and 9 on your own and tell me what translations are going to happen. So in number 8, I'm just going to write the vertex form up here. So a times x minus h squared plus k. So I see H, that's Hank. He's shady. He's on the inside. He's going to lie to me. And Kelly's on the outside. She tells the truth. We don't know what A does just yet, and we don't have an A value. So in 8, I see plus 3, so I know I'm going to go up 3. Plus 2 means left 2. Then for number 9, I've got minus 4, and so that means I'm going to go down 4. And then minus 4 on the inside means I'm going to go to the right 4. So maybe you've been trying to predict what A might do now that we've seen what H and K do. So when I have that coefficient in the front, that's going to compress or stretch my quadratic equation. So looking at G, and so maybe off to the side, so we know A is either a stretch, so that's where it gets skinny. So if you feel the need to write skinny next to stretch, so you remember. And then it could either stretch or compress. So it gets fat. Whoa, sorry, did not mean to change the slide there. Okay, so in my first example, here's my parent function right in the middle. There's my parent function. And then I changed it to 1/2 x. And so I see that it compressed. So it vertically compressed. And then in my example H, I see that I have a coefficient that's 3. And so when comparing it to the parent function right here, that's the one that says f of x, my g of x, notice how I got really skinny, okay? And so that is a vertical stretch. So vertical stretch. And you know, that makes sense because I'm going to be multiplying, like if I plug in 1 for x, okay, and I multiply it by 3 and then I square that, that's going to give me 9. So that just escalated real quick, okay? It shoots up. So I can make the argument that when A, okay, when the absolute value of A, okay, so meaning I don't care if that's a negative A value or a positive, if it's greater than 0 or less than 1, it's going to be vertically compressed. So any decimals or fractions, okay, that's a fancy way of saying it. And then any absolute value of A that is greater than 1 means it's going to stretch. Okay, so those are super important. Make sure you've got those written down. So I'll do 10 with you, and I want you guys to try 11 and 12 on your own. So in number 10, I would say that this is a vertical stretch because of the 2. So A is greater than 1, so it's going to shoot up real quick. So now try 11 and 12. So for number 11, I would say this is a vertical, always going to be a vertical, and it's going to be compressed. because the a value is less than 1. And then same goes for number 12. It is also going to be compressed. It is a decimal. Now, it's important to note if that was 1.25, okay, it's greater than 1, it's going to be stretched, okay? So then finally, we're going to look at A can also reflect your parabola, okay? So A can also reflect. And we know it's going to reflect simply by whether or not it's positive or negative. So looking at our first example, I see my parent function here, it's upright, and now when I graph the negative 2x squared, not only is it stretched, right, because of the 2, but it's also reflected. It's reflected over the x-axis. Now, notice how J looks almost the exact same. The only difference is that we have a set of parentheses. The difference is that square, okay, this power of 2 gets applied to the negative 2, whereas here on example I, it's only getting applied to the x, not the negative 2. So really, I could actually rewrite this P of x is equal to, well, I know negative 2 squared is positive 4. So that's why I see that compared to my parent function here, not only is it stretched, but it is also opening upward. It's not reflected. So looking at number 13, this practice here, I would actually simplify this. So the function r of x is equal to, now technically there's a negative 1 there. Well, if I square that, that's just going to be positive 1 and x. So this is just 2x. So it's not reflected, but it does have a stretch. Now in number 14, notice how the 2 is only getting applied to the x. So not only is it compressed because my a value is less than 1, it is also going to be reflected. And then finally number 15, okay, the power of 2 is being applied to the 3 as well, that negative 3. So really this is 9x squared. So it is going to only be stretched. So now let's put it all together. Let's review all of our transformations. And so I would write at the very top of your directions here, let's write vertex form one more time. So that's going to be f of x is equal to a times x minus h squared plus k. So now we kind of have that as a reference. Hank is on the inside. He's hiding something. He's shady. He lies. Kelly's on the outside. She tells the truth. And A is going to stretch, compress, or reflect. Okay? So looking at number 1, I would say we have Kelly on the outside. We're just going to go down 11. Number 2, okay, we have an A value. So I'm going to have a compression. So I would say it's compressed. And I see Hank in there, minus 2. So I'm going to go right 2. Then for number 3, I just have an A value that's also on the inside of the parentheses. So really that's actually 36x squared. That's going to be super stretched. Super stretched. And number 4, I have an A value that's also negative. So I'm going to be stretched. It's going to reflect. And we have got Hank, and we're going to go to the left 3. Then in number 5, I've got them all. So I've got an A value. So I'm going to be stretched. And I've got Hank. I'm going to go to the right by 3. And I've got Kelly. So I'm going to go up 8. And then number 6. Number 6 looks like a mistake. So let me just see something really quick. Nope, it's not. Okay, so I would actually probably rewrite this. Let's put this in standard form. So h of x is equal to 5 over 2. Oops, there's no parentheses. What am I doing? X squared plus 3. Ooh, I like this one. I would start that one. The reason I like this one is because we have an A value, and we're all going to think because it's a fraction that we're going to be compressed, right? Because whenever A is less than 1, it's compressed. However, that's actually 2.5, right? So that's actually going to be stretched. They're hoping to trick you because it's a fraction. And then I've got plus 3, so that's Kelly. We're going to go up 3. So let's see if you guys can do the challenge totally on your own. So we have an A value that's greater than 1, so that means we're going to be stretched. We got Hank. All right, so we're going to go to the left 1, and then we're going to go up by 2.6.